Welcome back to CodinGame. Fall Challenge 2023. Hello, DIJ. Okay, so it seems the Gold League is opened. So once that happens, a lot of people get promoted to Gold. Obviously, I'm still in Silver. We haven't really... Well, I've still got a lot of work to do here. Oh, it's only just over 5 days left. So, what did I want to do now? Let's test out my code. So I think I want to take some... So right now we're being very cautious. The moment we get the scan, we go straight back to the top. That was enough to get us to Silver, but now I think we've got to do the exact opposite. We've got to not be cautious, we've got to actually get the scans and get to the top without being hunted down by the fish. What's this? He's actually using emojis. Interesting. You can use emojis in your debugging. You can have them... Alright, well, let's put all these things on as well. Okay, so... Let's start by looking at the list of tasks. Creature's map should keep track of last known position. It does. Can use vector algebra. That's not as important now. We can take that out. I've done that. Some bonus points may be locked in. Well, that's not really a task, is it? That's just a statement. Some bonus points may be locked in. Don't output these. Not a big deal. Take that out. Extract some of this stuff as methods. Yeah, well, we should just be doing that all the time. I don't need to set it as a completable task. To do avoid monsters. Yes, that's the big one. We should do that. Keep reserve charge in case of emergencies. What kind of emergencies are we talking about? I think we're sort of already doing that, aren't we? I think I'm always leaving 5 charge so that when we see a fish and we want to catch it, we somewhere there's some code, I think. Let's see if I can find it. So when do we actually... It's in this bit here. Search for fish. Ah. So we're not doing it anymore. We were doing it. I must have kind of removed it without realizing. So I would say only use our light if it will leave at least 5 units of charge left after using it, because we need to keep 5 for emergencies. So I mean, does it matter? Let's have a think. Do we always just want to turn on our light whenever we can? If we used our light last turn, then we wouldn't, would we? Or would we? I don't know. Okay, for now we'll just use it whenever we can, but I would say... yeah, leave at least 5 units of... So let's say, drone dot battery is at least 2 times light charge. Okay. Will that make any major change? Probably not. 6 points versus 93. What's gonna happen? It's gonna be the same, probably. Yeah. Okay. Well, that's a minor thing. What else? Alright. Keep looking for the to-dos. So I am doing that now. Essentially, that's all I needed to do it. If we have potential bonus points exceeding a threshold, head to surface. Too vague. Take that out. To do, just chase the rest of the fish away. Yeah, I'll leave that because there's no reason not to do that. Like, once you've handed in all your fish, the game will calculate whether it's still possible for your opponent to catch up. So if the game is still going at that point, then it must still be possible for them to catch up. In which case, the best thing you can do is go around chasing all the fish away to try to delay the opponent from actually getting the fish, prevent them altogether from getting the fish. So yeah, I'll leave that as a to-do. It's a minor to-do because it only comes up in the situation where you already likely won, but it's good to do because you're securing the win. All right, well that's just that. All right, to do, avoid monsters. Well, the other big to do, I think, is to actually we're going. Alright, this one's a bit weird. We're going towards the furthest creature. I think I want to put a to-do back, which is something I was going to do before, but kind of abandoned. Want to... Well, in general, we'll have enough charge to get them all, won't we? So... So we're saying... See, this statement doesn't make sense right now, so... If we can see them, then they are in our radius. Also, this is horribly flawed. Oh no, it's not, because this is for our drone, okay. Right, okay, I think... So we find out which is the furthest creature away. Why do we do this? Because we want to know whether we actually need to turn the light on or not. And I've not really used this properly, so I should be saying... Oh, I get it now. It's saying if it's within our smaller radius, then we stay still, but we don't turn the light on. Okay, that's fine then. And if it's here, that means it's in our big radius. That means we need to... If we have charge, then we use the light. Otherwise, so the otherwise here is so in this unlikely situation here, we would go towards it. Now we don't really want to do that. Ideally, because there's multiple scans. If we go towards the furthest, we might be losing some of the other scans. Ideally, we want to go somewhere in the middle so we can try to capture all of them, or as many as possible. But that requires us a bit of a geometry calculation or something, so leave that there. Alright, so that's that. Okay. I think... how can we take some of these methods out, because this is a bit messy. So let me just grab my coffee. So I want subroutines to replicate this stuff. So okay, let's look at the first thing. So it's saying check for creatures in range. So the result is we either stay still or go somewhere. Hang on, let me have a think. So what if we had a routine which was called scan creatures in range? All right, and this routine is equipped to... It takes a drone and it simply gives the command for it to either move or stay still or whatever, to give it the movements in order to scan creatures in range. And this method returns the Boolean, true or false. True if it actually gave them a command. False if it failed, and then we, in that case, we move on to the next, to a different alternative decision process for the drone. So I think the very first thing we should have is not this. It's escape from monsters. So right. Okay, so let's do this. We want a method which is scan creatures in scan nearby fish. I'm just going to call them fish from now on. See if I can change all the elements, all the... Hang on. Should we just do one big change here? Rename every... Oh, no. There's a reason we use creatures now, which wasn't apparent in the previous leaves, because of the monsters. So we should be using fish. Yeah, so fish is the term we want to use if we're scanning fish and not monsters. Creatures includes the monsters right now. That's something we need to sort out. In fact, change this to fish in range. Well, we'll do it in the method. Okay, scan nearby fish. Right, so first, we get all the fish in range. So let's use F for F in self.visible creatures. So that includes monsters. If okay. Where do we use this all my scans thing? A couple of times, yeah. I think the cleanest way to do this then, because it needs access to the scanned. We can create all my scan multiple times. It's a bit wasteful, but it's not a big deal. Let me remind myself. So you need to end your turn. So in order to scan, you need to end your turn within the radius. Where's scanning described again? At the end of the turn. And they need to be within 800. Okay, that's fine. All right, so yeah, so yeah, we can create duplicates of this. It doesn't matter. All right, all my scanned. That so basically scan nearby fish if they are not already scanned, either reported or scanned by some drone. So say this. So if fish is not already scanned and we have a method for this, don't we? We can say self dot is within radius drone C. Is that how it works? We haven't used it often. So that's an entity, like a drone or a fish, and that's a drone or a fish. They both have pauses. Okay. Damn it. All right, just do that. So it's fish that are visible, they're not already scanned, they're within the big light radius of our drone, whether or not our light is on. I mean, it'd be a weird situation. Well, another drone could be seeing them, but then... it doesn't really matter. We can have them both scanned. Well, that does kind of matter. Like, if the two drones are near each other, we don't want them both scanning the same fish. We should actually give them each a target. So, that actually raises a good point. If we know... Using the radar, we know that a fish is, upright, northeast of us or whatever. But we also know that the fish is not near us. So its location is actually... should take into account the fact that it's not close to us, so it should be pushed a bit further. So we shouldn't be using the central projectile. We should actually be doing something a bit smarter. That matters because alright, you know what? I think we actually should not be having this this whole checking for creatures in range process at all. Instead, I think we should just be searching for a fish, a target, regardless of whether we know it's close by or not. Picking the one that's closest. And it may happen to be in range. In that case, we do the logic here. Don't need to do it up here. Because this all kind of comes under pick a target and go for it. Regardless of whether it's visible or not. If it's invisible, you just have an estimated location for it. If it's visible, then you have a solid location for it. So, hang on. So we should be like heading towards its position regardless of whether we see it or not. So I don't think we need to separate all this. So we can just take all this out and say, let's hide this for now. All right. So I don't think we need this method. I think we'd rather have a method for hunt. Hunt a fish. Right. So if there's the only time we wouldn't do this is if there's no fish left to hunt. In which case we would go to the surface. Okay. Hunt. Fish. Drone. Okay. This will return true or false, whether it actually is going to do that or not. If it's false, that means So if it's false, it means there are no targets to hunt, because otherwise we would always hunt one, right? Any reason we wouldn't hunt one? No. Well, we're assuming we're already dealing with fleeing from monsters before doing this. Okay, so hunt fish. So we do all this logic here, basically. Check for unscanned fish. Alright, so we want to get a list of all the scanned fish. We could actually kind of cheat here, and, well, not cheat, but we could actually lie and update the drone scans list as soon as we've kind of picked a target and gone for them. That will prevent the other drone from going for them. But we don't want to do that. There's only one fish left. We want both drones to go for them. There's no reason not to. Okay, yeah, don't do that. Alright, so, unscanned creatures equals set of monsters. Alright, let's rename this, because that is fish, not creatures. Does that not do the find and replace? Hang on. Rename symbol. Am I supposed to do it like this? There we go. Visible creatures, that includes monsters. So is everything okay? So we want unscanned fish equals the set of C for C in creatures.values if if C dot type is not equal to -1 and bounding box is not none, that means radar has seen it. Okay, so then we take away all the scanned ones, and that leaves us the fish we want to target. Alright. If not unscanned fish, return. Yeah. Okay, so we want to sort unscanned fish by we're going to need a set of already hunted fish to avoid those. Okay, so candidates equals list, sorted, unscanned fish, key equals lambda, f. We don't need that. It's already, Alright, so we want the distance. We're going to take the one with the shortest distance to us. But we also want to prioritize the ones which are not in the already hunted set. So just say f in already hunted. So if we're minimizing that value, that means we're prioritizing the false value. So f is not already hunted. So if it so happens that there's just one fish left, then we'll resort to taking one that is hunted. That's fine. Okay. And then we minimize the distance to the fish. So get predicted pos should just say we should change get predicted pos to actually give the actual pos if we happen to see it. Let's do that now. So get predicted pos. So if self.pos. So pos let's think. So if pos is I reckon we should change pos to be last pos. As in the last known pos. And it should be a tuple. And last pos equals none. the tuple is actually going to tell us the position and the turn we saw it in that position. And we can say, we can know if it's present if we look at its current position. So this, combined with the bounding box, can get us a better prediction. But for now, we can do the most basic thing, which is, if it's current, that's its position. Otherwise, just take the center of the bounding box. That's nice and simple. So a whole bunch of things are going to have to get changed here. So if... First, we need a global variable called, let's say, game turn. Let's say for game turn in count. Are we using it anywhere? Num turn. Why? Okay, we don't actually want it to be a game variable. Just make it a global variable. It's easier that way. Don't think we were using it anywhere anyway. Game turn. So game turn will start from 0. Alright, so when we see the pause, every time we see the pause, where do we see the creatures? Here. No, visible creatures here. So creatures pause equals, so we actually want that to be that and a copy of game turn. So that'll be the position and the time in which it was set. Velocity, we don't care about the time for now. But that also, well, that'll be, we'll get that from the position. Alright, so is that the only place we need to do that? Yeah, for all visible creatures, we update their last known position. That's for monsters as well. So then, here we can say get predicted position. And you can make it smarter by looking at their last known position, judging how far they could have gone in that time, given their velocity. And that means you can cut down the bounding box, but you can cut out that area where you know where they can't, where you know, well, it's the intersection of a box with a disk, isn't it? Essentially, that's what you get. You could approximate the disk to the smallest square that contains that disk or something like that. Or you could actually do convex intersections of sets. I don't know. It doesn't matter. For now, we'll just do the simple thing. So if self.last pause the time parameter is the same as the current game turn. That means it's current. Just return self.last pause 0. Otherwise, do this thing. Alright, so that's improved get predicted pause. Alright, so let's go back to this method. Alright, so we've got candidates. We've sorted them by their Okay, we've asserted that there must be fish in this list, otherwise we return false. So we don't need to do this. We can say, don't need to to make it a list, we can just say, or not hunted fish. Okay, we don't need to do that. So target fish equals in fact, we just do this. Target fish equals the min of unscanned fish according to that key. We don't need to sort a list. Okay, just get the min. Alright, that's more efficient. So we get the target fish, and we move the drone to its predicted position. So this, regardless of whether we see it or not, will go towards its position. And we'll activate the drone battery if let's think. When should we activate the battery? We kind of always want to activate the battery, but if we see the fish, there's one case where we alright, there's a bit of logic here that I can't be bothered to do, but let's say if tell you what, let's just always use the light whenever we can. We don't need emergency battery right now. Oh, why did I put those in caps? Just always use the light whenever we can. Right. Hunted fish.add target fish. Oh yeah. Already hunted. Add target fish. Alright, so that's the method. Nice and compact. It handles both this logic and this logic kind of in one. So we can take this out. So we can just say let's test it out. So it'll be a little bit different because we're not prioritizing the nearby ones now. Unless we were to put this up here, but we do want these to take precedence. That this is all not used anymore. So we just want to say if hunt fish drone already hunted, then continue. We have succeeded in finding a target to hunt. So if we didn't, so if we reach this point here, probably means there was no target to hunt. So I would say for now, let's just, okay, we'll put this thing here. For now, we'll just do that. Okay, so that's way condensed. This makes the decision method, like this is the one that gets called. This makes it way more readable because we don't put too much of this logic, and that was bringing me down before because I kept having to decipher this. Now you can see what we're doing here. Could just say hunt, pick closest fish and hunt it. Right, that's basically what we're doing here. We're still reporting scans ASAP. We don't really want to do that, but we'll do that for now because we're not handling the monsters safely. All my scans. Did I? Yeah, we're not using this. Did I actually make already hunted a class variable of drone? That would be interesting. I never really use class variables. But this might be a case where we would. Wait, no, drones are... That would be interesting because it's keeping track of what all the drones are hunting and it's stored in a class variable, so it's done for every instance. I don't know if that's the way you're supposed to use class variables. I don't think I've ever actually used them. Hello, Formy1. Sorry, I didn't notice your message earlier. Are you doing CodinGame as well? The full challenge? So, alright, for now, we can just make a note. Let's just run this. I don't know if this is going to work now. We changed a lot of stuff. What's this? Update bounding box. Oh no, that's fine. Oh, I have to return true. I don't need that one. Okay, let's try running it. So is it gonna? It's probably gonna crash at first. It always does. Oh, we got more points that time. What was actually the change to the logic? Mostly that was just a refactor, but okay, let's actually get rid of the comments. Oh, we'll take that to do out. Take that to do out. That would go under hunt fish. So this is a way of improving this. We can say when we move, we can actually move to the position which actually captures as many fish in one go. So to do that, we would actually use a list here instead of just the minimum, just picking one target. So we use a list. We actually want to find the position on the board within range, which would capture the most of that list. Is a bit more complex. But, I mean, it's an improvement. We can leave that there. Yeah, everything else, just discard that. My reports creatures. What? My reports creatures. That's not even a thing. It wasn't even a thing before. Why is that even working? My reports creatures. Oh my god. So that's just using that variable down there. Technically that's correct, but no, it's not. Well, it happens to be correct because that is the same variable, but we should be using self.myReports, and it should be fish, not creatures. Yeah, I've got to be careful of using variables from outside the game because that could have been very wrong and would have been very hard to debug. I mean, my IDE when I use PyCharm normally warns me about that. And I normally ignore the warning and do it all the time, especially if I'm doing mathematical coding stuff. I just can't be bothered to use proper... What's the term? Ah, Ku, hi. Glad I'm finally able to catch this live. Is this the first time you caught me live? Oh yeah, yeah, because last time I was playing Doom, wasn't I? Huh. Yeah, so I'm kind of steering my code to be more like, well, more like yours. But I mean, also because I actually tried a few of the top fish, and they all seem to be top competitors, not fish. And they all seem to be doing a similar strategy to yours, which is to err on the side of scanning more and resurfacing less often. Or at least what I'm right at this very minute, I'm just resurfacing every time I get a point because I don't have any good escape code. Just missed the first 50 minutes of this one. All right. Yeah, so I've basically cleaned up this code a bit. So this is just a major refactor. Now I've got this method called just hunt fish that handles all the pick a target and hunt it down. So now my kind of like main method just looks a bit cleaner. Some people definitely beat me by surfacing earlier than I do. Yeah. Well, it seems like it's definitely going to be better than just surfacing every time I get points. But yeah, once I've got some monster avoiding code, then I can actually think about setting a threshold. Well, it's not even a threshold. I guess part of it is you gotta look at how many bonus points you have pending compared with what the enemy's got. I guess some sort of... Yeah, I'm not sure. Some sort of multi-values threshold. I think my flea code is suboptimal. It's some complicated math. I mean, I guess right now all I would do is just move as far as I can in the opposite direction of the monster. To begin with. And then I can think about moving to non-dangerous spots which are closer to the monster but still on my way to where I want to go. Find lots of possibilities and seeing what works. Compute the optimal angle to dodge away at mathematically. Optimal in what sense? As in not steering you away from your intended target? Because if your goal is purely escaping, then optimal would just mean just swim in the opposite direction of the monster, right? But obviously that's not... Well, that's not... At a high-level strategy, that wouldn't be your goal. That's what I did initially too, just move directly from the monster. Yeah, okay. Alright. Replaced it with code that tries different angles and find the angle that isn't in range of the monster and is closest to my intended target. I mean, can you not just iterate through all the points in range? Is it too many? It's like... just be like, I don't know, I guess roughly the square of 800 or something like that. Could you not just iterate through all those points, or like 1/5 of those points or something like that? Right. This change actually resulted in an improvement against this boss. I could try submitting it. What is the... I guess... this is an improvement because now I'm identifying fish rather than creatures, because monsters were coming through into my hunting codes. So now we're making sure it's only monsters we're hunting for. I mean, that alone is probably a big change, because now we're not actually hunting down monsters. Pi over 2 times 600 squared points. But with only 2 drones, is that actually really that many? Like, do you actually get timeouts if you... One thing that sucks is that it is possible for a monster to come out of nowhere and eat you before you even see him. Mm. Yeah. But in that situation, there's nothing you could have done, I guess. Unless, well, I don't know, using the radar, you could have... If you knew the full history of all the radar blips of the monster at all times, you could have a good sense for where he is, but that's more complicated. But the information is there to do something smarter. Wondering how I can try to work out how to purposely bait monsters into attacking my enemy's drones before they can react. Oh man, that sounds risky. $565,460. What's the time? 50 milliseconds. Yeah. I haven't found the ideal way to keep track of the radar over time. Yeah, Well, what do you mean keep track of the radar? I mean, you could just store the full list of blips, the full history of blips, and the positions you were in. So that would be keeping track. Do you mean what to actually do with that history? So it would just be like a list of boxes, I suppose, of where you knew exactly where the monster was. How can you best estimate a fish monster's current location Even the radar history. Oh yeah, no, that's the bit I don't know. I thought you meant, by keep track, I thought you meant actually just, store the information, but, yeah, no, I don't think there's any easy, well, I mean, you can run simulations, so you can guess starting positions and starting velocities. Well, I don't know, what kind of, okay, they stay still to begin with, so we know that, so... Oh, you know where the enemy is at all times. So if you see the enemy at a certain place and then you see that the radar, that the bounding box has changed, then you can sort of infer that it is chasing the enemy. But then, yeah, I don't know. It's probably not very accurate because if your drone is far away from the monster anyway, you wouldn't see any change. You just see the same blip you saw before. I suppose you can also, if you see an enemy take a sharp turn, you can probably guess that he's running from a monster because there's no other reason to do that. Well, other than I suppose if you've scanned your fish and you're going for a different fish, but. You can detect when they scan something. Oh yeah. Yeah, so if you saw them take a sharp turn without scanning something new, then they probably never reached their intended target and are actually escaping from a monster. See them gain a scan. And you know that fish is within 800. Oh yeah, that's valuable information, yeah. One of their... And you'd know which drone as well, wouldn't you? Yeah, well... Yeah, you would. You would know the position of the drone as well, so... Yeah. So that... And you would know... Would you know if their light was on? No, that doesn't come in the inputs, I guess, so... But you would know... Oh, you would know their light. You would know their battery, so if you see the battery drop, then you know they've used their light. Yeah, so you do know when you've used their light, so you'd know exactly... Hello, Dahi Ninja. Yeah, so you can infer quite a lot of stuff. I guess I should be doing that, because that would really narrow down their position, and that's like, let me make a note of that then. Predicted position. I mean, there's several things you can use here. So one is, if enemy scans a fish, we get a known disk of light radius for the position. That's good. Let me try submitting what I have now, just because it's actually not trying to hunt down monsters. Could be an improvement, but then I also moved some things around, so I don't know. I mean, for this one, it's... Okay, whatever, let's just submit it. Okay, so what else? I've only got like about an hour left before I gotta go to the gym. So I can't really start on... Well, I could start on the monster code. I mean, if I'm going for the most basic thing, then it's just a vector, isn't it? It's like... Alright, let's see if I can do this. So... Avoid monsters, so... So we can make a separate method for this. So basically, as before, it returns true if the drone is now busy avoiding monsters, false if nothing really happened. Oops. Do you not avoid monsters at all yet? No. I mean, when I reached Silver League, I was still using the... When did monsters get introduced? Bronze League, I guess. But... I guess I managed to qualify before I ever really did anything about the monsters. Did I? Yeah, because normally bronze is when all the rules get introduced. Like, yeah, it seems like it was. Okay, that's weird. Did I really qualify without doing anything about the monsters? I think it's because I was just being really cautious, just going back. Yeah, so yeah, when I got to bronze, I was failing hard because of the monsters, but then I just made one change, which was just every time I get any scan whatsoever, just go to the surface. And that seemed to work, actually. It seemed to beat the boss. So yeah, for the Bronze League, I think just surfacing every time I got points was fine. The boss was actually getting killed by the monsters a lot. Well, not getting killed, but getting chased by the monsters a lot. Like, a couple of runs, he was getting 0 points, so... Alright, so... I'm not using that variable anymore. Okay, so, avoid monsters. So, let's get a list of monsters within range. So, it's basically similar to this. So, but it's going to be... It's going to be monsters in range. So they're going to be visible, I guess, because oh, we can see them. We can see them further than the light, so ignore the light variable. Just say visible monsters. Just get the full list of visible monsters. Equals, it's going to be, we want to do something like okay, just write it from scratch. So it's going to be C or CN visible creatures if C dot type is -1. That's just it. So okay, so for a given drone, we include even the monsters that are maybe far away, seen by some other drone. It doesn't matter. Just get a full list of all the monsters and their ranges, and then we'll figure out what to do, whether we even care for each one. So should we just say, just worry about the closest one? So if not, there's no visible monsters, return false. Okay, so closest equals minimum visible. By the way, Ku, you're using are you using Python? Closest visible monsters. So far, yes, I'm using Python. Yeah, I think this... You went with C++ E Skyline. Sometimes I switch to C++ towards the end if I feel speed bound. Yeah. Yeah, I remember that Pac-Man one, it seemed like using C++ or something was a good change. Not something that I would want to do myself. I'd probably just stick with Python. But yeah, to be competitive, it seemed like it helped. Did you have a look at Advent of Code this year, by the way? It was a busy month for me, but I managed to finish all the problems. It was pretty good. Some nice problems there. There were no assembly code problems this year, although even though I hate them, I kind of miss them since he didn't put any of them in. People always complain about them, but they do. I mean, they are good problems. There's lots of good heuristics in this game, and language speed my only math for legend. Yeah, I mean, if you look at the leaderboards, there usually are lots of people still using Python, even at the top of the leaderboards. Sometimes even in the top spot, the top 3 spots. It's often the case. So yeah. And I mean, it's not always necessarily disadvantaged because they may give different time bounds for Python. I don't know if they're doing that this time round, but if they give different time bounds for Python, then it really what matters is how it compares with the time bound you've been given for that language, doesn't it? So can you get NumPy for free? Yeah. Yeah, I keep meaning to use NumPy more often, like in problems, because I mean it's really obviously it's a really good library. I just keep not touching it because I'm I'm lazy to learn the syntax and stuff, but in the advent of code, I did use it for a couple of problems, and it was pretty good. I mean, there was one problem begging for NumPy, and that was a major linear algebra problem, which I think most people found the hardest problem from a kind of like a technical difficulty level, because it involved... If it involved proper, like, university level linear algebra, I can't remember which problem that was. Let's have... Towards the end, I think it was the final 3 days or something. You want to use neural nets, Python with NumPy is super legit compared to C++. Yeah, I imagine that's probably the case. I think it was like day 23, not 23. Yeah, this one. Oh man. I think this took me like 6 hours or something, and my linear algebra is really rusty. But the gist of it is that you have a bunch of hailstones in 3D space, and you want to find how to throw your rock. So you're going to throw your rock from an initial starting position and initial velocity, and there's no gravity or anything, and you want to see how you're supposed to throw your rock in order to hit every single hailstone. And they're all moving about, so you know where they're moving, what velocity they have, what position they have. You need to know how to throw your rock so that it hits every stone. And there's like more than like 1,200 stones. It's a pretty crazy problem. But you can just plug in, what was it called? Something beginning with Z that a lot of people used. ZSum. There's a Microsoft library that has a Python module that seems not possible. Well, no, it's possible because the input was specially designed for it to be possible. But the general case, it's like negligibly, it's like never going to happen. Yeah, that's right. But assuming it does happen for this input, you have to find the position. It's actually, I mean, it's not actually, from a linear algebra perspective, it's not actually that hard. In fact, you only need like 3 or 4 hailstones to actually mathematically solve the system. You don't need all 1,000, but it's kind of, it's quite hard though, because it's not, even when you set up your matrix of like simultaneous equations, it's not that obvious how to proceed. It wasn't to me, at least. Like it wasn't just a case of just setting ax equals b and then using a Gaussian elimination to solve for a and b. It just, there was a trick to it. I can't remember what it was. So using pure NumPy alone even was quite tough, but there was something more complex, which was like a constraint solver. I can't remember what it was called now. Let me see. It's made by Microsoft, so it's like Microsoft something beginning with Z. Z3, that's it. A lot of people, I think most people who solved it actually use Z3, and there's a Z3 Python module. But Z3, you don't need to use any matrices or anything. You just tell it all the constraints, and it just figures it out. Just tries lots of smart methods of solving until it figures out what kind of routine to use. For AOC, you can use arbitrary Python modules. Yeah, sure, you can use anything, as long as it's not like a ChatGPT or a language model or something, then it's fair play. CG, you certainly can't. Oh, yeah, but that's just a consequence of it not being in the in the engine, but in Advent of Code, since you're not running anything on the website, you can use whatever you want as long as you're not using ChatGPT, basically, or just anything similar to ChatGPT. By the way, there's a collision function in the Git repo in the description. You can just port that to Python and stick it in your path planning code to avoid monsters by default. Oh, really? I never really look at their starter code, but it is actually a pretty good, it often is quite good starter code. Alright. Well, I'll probably write my own first, and then I might look at it for inspiration. Every time I've been streaming, I never see anyone appear in this bar, so I guess it's just because people are busy with New Year's and Christmas and stuff, but I'm surprised because I suppose all the 4 challenges previously were just not at this time. Because it was always, in past competitions, there were always several people streaming, if not in English. Just surprised me that I don't see many these days. You get eaten if you're within 500 at any point within a turn. So even if you're 500 away at the beginning and end of your movement, you can still be eaten. Oh yeah. So I need to... I wouldn't... yeah. Solving a quadratic given the 2 positions and 2 velocities. Wait, what are the 2 velocities? What, using the max velocity of a drone? Okay. But if there's any... So what's the point of that? Are you talking about a method that's just saying true or false? Yes, I'm going to get eaten, or no, I can't escape, or something like that? Because does that actually give you anything useful? Or are you saying this is actually returning the position you're supposed to go to avoid? Or is it like this would just return true or false? Oh, I see. So it would return true or false for a given position, and it's up to you to try different positions. I see, yeah, okay. And velocities. Well... Wait, why... Okay. I suppose there's no real velocity as such, is there? It's just literally you're teleporting to certain positions within range. Like, I guess the... Oh, I see what you mean by velocity. Oh yeah, because you would need it to solve the quadratic. Okay, yeah. So you need to infer the... You do not teleport, you do move. Oh, no. I knew that you could be eaten mid-turn, but I thought... Wait, so is a movement... What is a movement? Is it a series of steps in the 10,000 by 10,000 grid? Like... Via, like, Manhattan metric or something like that? I mean, if you're moving from one point to another point, are you actually teleporting to that destination point? Or... Or is it sort of deducing where along that line you would have got eaten? Checks for all collisions at all points of the form. Wait, so T is... So it's actually solving the equation for like real valued T, or is it just for T's that would result in a like an integer location in the grid? It solves for real valued T. Okay, fine. So if it finds a root, then where do you actually end up? Do you get, because you're gonna get interrupted, aren't you? So does the movement actually still go through? Do you still end up at your destination, but you just become go into emergency mode, but you still actually make your movement, or you get interrupted and you only go halfway or something? You do make the move, but then you go into emergency mode. Okay, that is useful information then. I never really looked into it. Did they actually specify it to that detail here? I didn't. I might not have looked, or is this something you really needed to look into the code for? I know there were some details here, but it was more about the order. It's in the description. Well, I didn't see anything in the description about the fact that it's... Wait, let's have a look at this again. So where does it describe? Okay, so it's later on, isn't it? You know, fish, monsters. All right. If a drone is within a radius of 500 from a drone during a turn, so no, not necessarily at the end of the turn, the drone will enter emergency mode. I would have still thought it would teleport from the... I wouldn't think that description would actually mean it's solving for real valued... for real values. But if the... I mean, yeah, if the Git... the GitHub code actually explains it, then that's fine. But from this description... Not necessarily at the end of the turn, but I think of... Yeah, so I think of its starting position, your drone's starting position, and your ending position as two discrete points in your turn. But what happens in between those points is never really specified, so I always thought of it as the drone teleports from your starting position to your destination point. And that's still in line with this saying not necessarily at the end of your turn, because those are two steps within the turn. But I didn't think it's actually going as far as simulating, like, T is real valued in their collision code. Oh yeah, I get that now that you've explained it. But I'm just saying, I don't think that was... I didn't get that from the description. So yeah, it seems like that's something you really needed to look into the actual code for, because on this, I wouldn't have presumed that. I actually thought the discrete movement made more sense to me from this wording. But yeah, that's good to know now. Because that makes a world of difference. Because I never even fully... So I guess distance, they're going by Euclidean distance. I mean, I have assumed that, so I've coded in Euclidean distance, not like Manhattan distance or something. That would be sensible. The advanced players will just look at the GitHub. Yeah. Okay, so in that case, well, my strategy is still going to be just go in the opposite direction, so closest will be the minimum of visible monsters for that. Interesting. Oh no, they're not going to have a get predicted position, are they? We're actually going to know their position. So, pause. In a couple of weeks' time, I'm going to be teaching a workshop at the university, and I'm going to be teaching them CodinGame. And I did this same course last year, but last year I used the I gave the students the hypersonic Bomberman game as like a yeah. Which uni is this? In Vietnam or back in England? No, in Saudi Arabia. I was invited to the last 2 years I've been invited to do this course. So the first year seems they liked the course, but the first year was during COVID, so I did it remotely. But last year I got flown in to do it. It was only 3 days long though. I would have preferred it to be longer. But this year they've upgraded it to 5 days, which is better because now I can actually cover more than just BFS, and I only really got as far as A star within the 3 days. So you're physically flying to Saudi? Yeah. It's a university I did a course at before in the past, so I'm familiar with it. Yeah, it's pretty fun, and the students are mostly like postgraduate students in mathematical sciences, so they're usually more adept than the standard undergraduate computer science student. Although they may be not in computer science, they may be in like statistics or electrical engineering, but usually they would have signed up for the course only if they actually know a bit of programming and stuff, at least. So yeah, there's that. I think I might give them this game because it's more recent, and the only thing is it won't let them practice the main thing that I'm going to focus on in the workshop, and that's pathfinding. So that's an argument for still using the Bomberman one. Unless you can think of another past competition which would also be good for pathfinding. That's the main reason I picked Bomberman, because the main thing I'm teaching is like breadth first search, and maybe just touch A-star search, but I probably don't need to. The Pac-Man one, yeah, actually I might have considered that at one point as well. I'm trying to choose one which would be kind of like the easiest for them to jump into and get a most basic working code. Because they won't have much time. It'll be 5 days only, and they've got other courses to do during this event, this winter event. So they won't really have much time at home to be able to work on their scripts. So I mean, I would like it to be the most entry-level thing I can find that will let them actually get something where they can move their guys from place to place. But so I still think Bomberman might be conceptually the easiest, but I'm not sure. Yeah, now that I think about it, I don't particularly want to do this one because I think it's important to have something where they'll be using BFS just because this type of AI here is not as easy to teach because it's not really a paradigm. It's just like being smart about like states and state transitions. But Bomberman has like textbook algorithms that you can use. That might be a better instructional case. Yeah, I'll probably stick with Bomberman. Yeah, because last year it was pretty rushed. It was only 3 days, and so I gave them the... So basically, during the workshop, I'm just teaching, like, you know, the algorithms and then showing examples, maybe solving some of the puzzles on CodinGame, and then I'm giving them, like, homework or optional homework, like, at home they can work on their own bot. And at the end of the whole thing, whoever has... They're all going to enter their bot into the league, and whoever has the best bot will get prizes, and the university is paying for the prizes. But I think the winner last year, he mostly won just by staying still. Well, I think he might have dropped a few bombs, but pretty much staying still let him perform better than the other students in the workshop because they were getting themselves killed a lot. Well, actually, okay, so for like the Wood League, you can't get killed. So if you want to progress from the Wood League, you need to move about. But then once you get to like Bronze League, then if you just switch off your code and just let them stand still, you actually get pretty high. Because a lot of people who are just using their Wood code and not completely overhauling it are just dying to the bombs. I guess that's the reason. So it's not really the case that he just did Wild True Weight. It's more that he did have good code for beating Wood, but when he got to Bronze, he realized at that point, if he literally just switched to staying still, he actually came out top. So it's fine. He actually did work to progress in the first place. I think the other students who just managed to get into Bronze, they just kind of left their code roughly how it was before, but tried to make changes, but they were still dying to bombs. So this student that realized that staying still was winning at that point, I think that's fine. It's a pretty smart decision. Alright, I'm not... I've got like 30 minutes left. I can maybe get this monster thing done. Does it not like this? Oh, it's just one of these warnings. Doesn't matter. Okay, so we've got the closest monster. Now what? You get the vector. So you get the vector. You get the vector. You want to get the vector which takes you from the monster to me, and then add that vector to me, but multiply it by. If you just give the drone a really far away position, even if it's off the map, is that still allowed? Or does it have to be a position that's in the map? It's allowed? Even if it's like negative? Okay, well then I can just normalize. Yeah. Okay, I mean, kind of makes sense for me to do that just so I actually know where it's going to end up, but trying to be clever with respect to the edges of the map. Yeah, well, it'd really just be a case of taking the faraway position and then doing... Hang hang on. Okay, so closest. Alright, so vector equals position. It's going to be. Wait, did I define subtraction on position? Well, I should. I'll just do closest. It's going to be me minus closest, isn't it? Drone.pause minus closest.pause. Left edge of monsters, just your right. Yeah, there's some weird stuff you want to do around edges. I guess edge case, that needs to be handled as well, but yeah, let's make a note of that. So I guess I can add some methods to pause, like normalize. So like, I don't know, get unit vector. Oh, not here. What would I want? I would want get unit vector, so get well, no, would we really? Can you give floating points as move? No, I guess not. But we can just round down. Okay. That's the point. I should have devised my code to always round down in case floating points slip in, which I'll probably want to do at some point. So move. So it would have to be int post.x. Hang on. No, I devised this to always be ints. Do I want to keep it that way? Probably should. Okay, we'll just do all the geometry in the method then. So the norm would be just say norm squared equals well, we can just find the square root. Norm equals square root of vector dot x squared plus vector dot y squared. Port math. And then is that right? And then unit vector. So we want 800 multiplied by the unit vector, basically. Yeah. So let's say heading. These are ambiguous. Vector heading. Right, for now. Heading equals. It's going to be 800, or I'll use the variable, which is move Oh, it's 600. Is it not 800? Yeah, it's 600. Okay, yeah. So it'd be 600. Move dist. So it's going to be pause. So it's going to be int of move dist times. So it'll be pos.x times move dist divided by norm. Wait, that is going to be vector. Okay, like that. With the y. Yeah. Okay. That's the heading. So my destination, we'll just say destination equals drone.pause plus that. So if we just give that as the movement, then there should be no errors. Wait, so what happens if you try to walk off the map? Will it just stay still? So if you're a bit away from the edge of the map, will you just get as close as possible and stop there? It will just click. Okay, fine. I guess that's fine for now. It's going to be bad when we get to the edges, though. So we'll need to do something about that, but... self.move drone.pause. Is there any reason to turn on the light? Well, not really. The thing is, we haven't really accounted for... We haven't addressed the distance, because there's a certain distance at which it's not a threat, so we need to evaluate that as well. So, okay, so self.move, and we don't want to put the light on. If the monster sees your light, it moves faster. I thought... I'm gonna read this again. I don't think I fully understand. If a monster's within 500, it gets you. Okay. If it sees your light, as in it's in your light. Within your light's radius. Ah, okay. If a Oh, I see. So when it's not... Oh, okay. So it's aggroed on you when it's in your light radius. And it goes towards you at 540. And if it's not within your light radius, but it has previously been aggroed on you, then... Well, not this. From that point on, regardless of whether it's been aggroed on you or some other drone or something other, it's always going to be going at 270 in that direction. So, like, in general, it's just going to be swimming around at 270 in some direction. until it gets aggroed on somebody again. So it could be in your light, but aggroed on a different drone. Ah. So nearest drone means nearest drone anywhere on the map. So there's no check for whether their lights are on or whatever. It just literally takes the nearest drone by XY position on the map. Oh, that's interesting. Oh, okay, so that makes what you said earlier, that makes more sense now when you said about intentionally aggroing monsters on enemy players. I didn't see how that would work at first. You're not sure. I see. Because if we're reading this... Yeah, because if we're taking this really literally, direction of the nearest drone says nothing about what any properties of that drone. So yeah, it seems from this description that it would just go towards the nearest drone anywhere on a map. Because it never said anything about their sight range or anything like that. They can probably, for all we know, they can see everything on the map at all times. It's just they only get aggroed the moment that a light hits them. I think it goes towards the nearest drone whose light it can see. Alright. If that's the case, I would say this is quite misleading then. Because that's a very specific set of drones that it would go for. I guess that's something I'll need to look up. Closest non-emergency mode drone whose light it can see. I'm gonna have to write a to-do to look into this either way. When monster is aggroed, which drone does it chase? So right now the most basic thing we can do is say if closest is within I don't know, if not self dot is within radius, drone closest, what radius should we say? So if it moves 540, so if I'm doing it this basic, where we just flee, or we don't actually be smart about paths that avoid monsters, we're literally just fleeing when the monsters are getting too close, then we have to choose the threshold such that we can never, so if we see a monster, we're never gonna step into a position that lets it eat us, which actually means we'd have to give it quite a wide berth. So if it moves 540 and we move 600, and it's just trying to get within 500 of us, that means we'd actually have to start fleeing from quite far away if we're going with this basic approach. I mean, if we're being as safe as possible, it would have to be 600 plus 500 plus 540, wouldn't it? Otherwise, we have to kind of adjust the movement path to better avoid the monster, but... Oh, I could just say if it's in my light radius, we flee. Because that kind of... Because then we know it's chasing us. So... Yeah, okay, whatever. Let's do that. And... We don't worry too much about the situation where it's not chasing us. We don't want to move closer to it. Well, okay, that's a bad situation too, but... Worry about that another time. Alright, so just say if light radius equals well, we don't get an input telling us whether our light is on, do we? We would have to work out for our own drone whether our light is on based on the battery count, unless we store memory from what we did last time. Ah, but if it's appearing invisible creatures, then it is actually in our light radius. So we can just assume... It just doesn't tell you which drone it is, so... Okay, fine. Let's just say... If it's within the big radius, then... Don't worry about checking whether our light is actually on or not. Okay, so... Oh man, I'm gonna have to stop soon. Okay, let's just try and do this and then submit it. Alright, so what was the code I just deleted? If it's not within that distance, then don't worry about it. That's 2000, so that's pretty okay. Because it's like... Unless we're going quite... at an angle that's quite towards it, then we actually might still be fairly safe, even if we move towards it. Really depends which way it's going and everything. Okay, so... just continue. No. Return false. Okay, return true. So... if I want to use that, we just say... That's it. It's already accounted for. Alright. Try that. Now, this could be much better, it could be much worse. It's probably gonna crash though. There we go. Less than not supported. Well, no, we shouldn't be trying to do less than. Drone dot pause dot dist m. M is a monster, and M has a pause. What? I had the same error before. How did I solve it before? I thought it was because I had a missing bracket or something. It says less than not supported between function and list. What? Oh. Oh. Min is doing less than, yeah, but this should be an int. So it says what we're getting here is trying to compare a function with a list. Visible monsters is a list of creatures. It's trying to find the minimum amongst the list. Oh! I forgot to type key equals lambda. The key is the comparator. So it's trying to find what's smaller, this list or this function. I made that same error before, I forgot about that. Tuple has no attribute X. Oh, we're trying to call. Oops, we're setting pos somewhere to be a tuple instead of a pos. How did that happen? Where are we doing this? That must be where we populated the monsters in the first place, right? Ah! Oh yeah, because we changed pos to be a tuple. We should really... Yeah, that's kind of bad. Alright, let's make a method. Pos... Let's actually do define get pos. So this method only makes sense if we know its position. So we shouldn't be trying to call this if we don't know its position. And there's no dot pos. Pos doesn't exist. Wait, what? It's called last pos. Oh, this is all gone horribly wrong. Why am I still setting it to be pos? Okay, a lot of things need fixing. Alright. Self dot last pos 0. Okay. That's the get pos method. Now when we're setting it, okay, that should be get pos. Alright, and this should be get pos. Alright. When we're setting it, we should be what? Creatures. So we set that should be last pos. There should be no pos anymore. I bet it's being referenced somewhere. Probably in this new method I wrote recently. Not that one. This one. No, because we use predicted pos. Okay, that's probably fine then. Alright, let's try that now. Oh, damn it, because now... Alright, tell you what. Let's just do this. We don't need a get pause method, just say... Yeah, this is actually not really good, having a tuple here like this. It's doing two things at once. Alright, let's call it last update. That's just the time at which we updated it. Alright, and then go back to using pause. We have all the information between those two things now. So they can be used independently if we want to, as long as we keep in mind that pause will be none if we've never seen that fish before. Alright. What a mess. Okay, got a bunch of things to change now. So now it makes sense to access pause. Let's do pause, because here we know that we've seen them because they're visible. Just pause. That's fine. Up here. That's fine, we're using predicted pause, and then when we set it, last, okay, so here we want pause equals that, and we want basically last update equals gator. Okay. Still something, probably still something that I need to change. Creature as no attribute last pause. Yeah. If last update, then return self.pause, otherwise do the bounding box calculation. Okay. That's much better. I don't know why I did that tuple thing, that was silly. Alright, 12 points like before. Alright, well, fine. The thing is, we're still heading to the surface the moment we get points. Let's turn that off now. Let's be a bit less... Oh, did it dodge? Well, I can try and see what's happening, but I hate the color choice here. That one is me, that one is me. Okay. No, it's not dodging. I don't see any evidence of it dodging. That one there. Let's see. We should probably log. Return true. Oh, destination was never used. So yeah, there's the fault. If we're doing the worst possible thing you could ever do, if you see a monster chasing you, freeze in place. It was just moving to its own position. Yeah, exactly. Yeah, some people do that when they're scared. Alright, right, let's run that again and see if he avoids. Okay, he goes to the edge, sort of. Yeah, he's dodging. See that one on the right? He's going off at angles, and he's not getting caught. It works. Now, let's just tell them to go hunt fish and not worry too much about monsters. Now, this might not be very good because the monster code might be a bit too rudimentary. I don't know. We'll see. Let's just turn that off. So only once we've got all the fish hunted, we'll go to the surface. Let's see what that looks like. I think it's quite likely we'll often get trapped at the edges. So that one and that one. So it makes it even more confusing when they keep changing colors. Alright, so he's getting chased. Oh, he got caught. Well, that's, yeah. That's to be expected with the code working as it is, because he was just going straight down and he could not see the monster. Although he could predict its position, I suppose, but that's a whole different thing. The last position was only one turn away, so that information is there. Just have to do something with it. Okay, fine. That's within expectations. The other guy is trying to get all the scans. We actually got more points that time, I guess. Yeah, as long as we just try to collect scans. I don't know how this will perform though. We could try submitting it, but it's like we now have a high risk of just losing lots of scans instead of banking them. But it'll tell us something. So let's see what happens. I mean, yeah, the bad situation comes up when your target is on the opposite side of the monster. Then you're going to keep getting chased, and then when you're out of range, you'll keep going towards it, so you're just bound to get caught by the monster. So I think we do need to do some sort of, like, using recent knowledge of the monsters. Like, it could be just discrete, it could be just say, alright, if it was in the last 2 turns or something, then assume he's there or within a certain disk around that area. Or it could be more like something I did for Pac-Man, which is like have a probability distribution for every cell, and as time goes on, like you have decay of the probability of him being there, or something like that, I don't know. You could check multiple moves to check which one gets you closer to the target and also avoids the monster. Yeah, I think that's a good approach as well. Like we could put, like, we could pick points around the disc, in the outskirts of the disc, and also within the disc as well. Maybe a few points. It doesn't have to be all of them, and try them all. Mark them as safe or dangerous. Alright, I need to stop. Oh. Can't really tell if that was better or not. It's still only 24%. But I mean, it's a step in the direction I want, so it's fine. I think we really need to do this one. Handle size of grid. And what was the other thing? I'm not quite sure what I want. Okay, it's not really a void monster code, it's more about hunting. That you can create a path, and you can sort of, like, I don't know, you can, let's say you construct a path of 5 points to get to your target, 5 arbitrary points in the grid, and say that's your path that you're going to follow. and you could like take the distance of this, which is just the sum of the segments, and then you could take the danger level, which is, I don't know, like the sum of squares of the distances of all the monsters, predicted points of the monsters to this closest point on this path, and try to find a path which balances those two values. So that would sort of steer you away from rough locations of monsters. And then you could also change that path to be like 10 points or 20 points or something, depending on what you can handle. And then just head to the first point in your path. Well, no, the number of points could just be, I don't know, the number of 600 unit jumps it takes to get to the goal. What you just described now is almost exactly how my own code works. Yeah. I'm starting to feel like it would approximate how I would handle, you know, driving a drone if I was in charge of it. Try and curve around hotspots. Could be quite lucrative. We just involve lots of, I mean, we could do lots of geometry to get better predicted positions, do something stuff to do with like heat. So say things are less hot if, you know, a monster has not recently been in that area, so it's kind of like cooler. So then you have some notion of like cooling down, like using like temperature decay or something. Might be interesting. I might start doing that next time. Alright. I've got to rush to the gym now. I'm not going to have much time to... Clearly, I'm just subconsciously trying to find an excuse to skip the gym. Can't let myself do that. I've no predictions yet except the monsters in my visible range. Okay. Does it work well? How is it doing? And have you tried, like, other strategies, and does it do better? What's your username, by the way? I could follow you on the board as well. Actually, I don't have time to do that now, but you can drop it in chat. X Skyline. Okay, I'll sort that out. 140 in gold. Nice. I'll sort that out offline. Alright, thanks for watching. I will be back. Well, we've only got 5 days left, so I'm going to try and do a bit every day if I can. So probably back tomorrow. So yeah, thanks for watching. See you guys next time.